Okay, in the previous lecture, we looked at this example on the slide. So we were working with a small sample and we tested the following hypothesis, that the mean is equal to 432 versus the right-sided alternative. And we made use of the rejection region method. And our final conclusion was that we reject the null hypothesis. We can now repeat this same example making use of the p-value method. So the first three steps would be exactly the same. And then for the p-value method, what we do is we would like to get the area to the right of my observed test statistic. So my observed test statistic is the 2.4139, and my p-value is the area to the right of my observed test statistic. Now, it is the area to the right of my observed test statistic because I tested the right-sided alternative. So my p-value will be this area. And you can make use of statistical software, something like Excel or any other appropriate software to calculate that area. And we will do that in just a while in Excel. But for now, you can assume that that area, the red area, is equal to 0.013. And then we compare this p-value with our level of significance. And our level of significance was 5%. And because the p-value is less than our level of significance, we reject the null hypothesis, the same conclusion that we got for the rejection region method. And then our final conclusion will also be exactly the same. Okay, so we can find the critical value for the rejection region method. We can find that in Excel as well as the p-value for the p-value method. So first of all, if we want to find the critical value, because we are testing a right-sided alternative, we make use of the following function. We use the t.inverse function, and then we take for the probability the area to the left of my critical value. Now, because we have a right-sided alternative, our critical value will lie to the right tail, and my alpha is 0.05, so the area to the right of my critical value is 5%, and the area to its left will then be 1 minus 0.05, so that will be my 0.95, and my degrees of freedom is 19. And then I get my critical value 1,729. And then also to find the p-value, the p-value is the area to the right of my observed test statistic. So I make use of the t.distribution.right-sided function. My x argument is my observed test statistic value. And my degrees of freedom is 19. And then you get 0.013. And that is exactly what we had on our slide. So there you can see that we get exactly the same p-value. And you can also go back to the rejection region method. And you can see that for the rejection region method, our critical value was the 1.729, and we got the same using either the tables or making use of Excel.